I am audible. Good afternoon.
Yes, sir, you are audible.
Okay, okay.
Okay.
So, a very good afternoon to one and all. On behalf of the organizing committee, I am welcoming to all the dignitaries, our eminent speaker for the day, and participants on this third day of faculty development program on future trends in machine learning and data science driven IoT applications, FTMLDSA-IoT 2025. Organized by the Department of CSC Data Science in association with the Internal Quality Assurance Cell of Haldia Institute of Technology and an autonomous NIRF ranked institute under IQAC Haldia in collaboration with the Department of CSC Budge Institute of Technology and the Department of CSC Dr. Sudhir Chandra Institute of Technology and Sports Complex. Participants are requested to follow the session attentively on the respective platforms as usual, and you can put up your questions for our eminent speaker via the designated chat box, and the attendance form will be shared in the chat box during the session, and it will remain open for approximately 1 hour. So please ensure your presence within the given time frame. So now today we are honored to have Professor Parthopratim Sarkar with us today. Dr. Sarkar did his PhD in engineering from Jadavpur University in the year 2002. He has obtained his ME from Jadavpur University in the year 1994. He earned his BE degree in Electronics and Telecommunication Engineering from Bengal Engineering College, presently known as Indian Institute of Engineering, Science and Technology, Shibpur, in the year 1991. He was in the rank of reader during the period January 1997 to January 2005. He is presently working as professor and senior scientific officer since January 2005 at the Department of Engineering and Technological Studies, University of Kolkata. His area of research includes microstrip antenna, microstrip filter, frequency selective surfaces, and artificial neural network. He has contributed approximately 373 research articles to various reputable journals and conferences. Among them, 244 research articles are in peer-reviewed international journals and 132 research articles are in ACI Index journals. He has supervised 26 number of PhD students, 78 number of MTech theses, and more than 100 BTech projects. He is also a life fellow of IETE, Institution of Electronics and Telecommunication Engineers, and IE in India. So, without any further delay, I am delighted to invite Professor Dr. Parthopratim Sarkar sir to deliver his talk on the topic frequency selective surface by artificial neural network to reduce the harmful effect of EM wave. Welcome, sir. Over to you.
Okay, I am sharing the screen.
Okay, sir.
Is it visible?
Yes, sir. It is visible.
So I'm starting. Good afternoon, everybody. Voice is clear?
Yes, sir. Voice is clear.
Okay,
Sir,
no problem.
sir, it would be
Huh.
better if you put it on full screen mode.
Okay. Now it is in full screen mode.
Yes, sir.
Okay.
Perfect.
Good afternoon, everybody. Today I am discussing design of frequency selective surface by artificial neural network to reduce harmful effect of EM wave. So there are three parts mainly. One is EM wave, that means electromagnetic wave or microwave. What is the harmful effect? We should know first. Then we shall discuss how we shall minimize this harmful effect by the design of frequency selective surface. And third one, we shall apply machine learning. One of the machine learning techniques used here is artificial neural network. But we may use artificial neural network or fuzzy logic or particle swarm optimization for design of frequency selective surface. Today, in this presentation, I shall discuss only artificial neural network to design frequency selective surface. So I am first explaining what is electromagnetic radiation. Any problem?
Sir, no problem, no problem. Hello? Hello? Sir, your voice is not coming. Hello? Yes, I can hear you. I'm fine. স্যারকে ফোনই করছি।
তখন কিন্তু মিউট করা ছিল না। হ্যালো,
Hello, sir. Hello.
now it is clear.
Yes, sir. It is clear.
মিউট করা ছিল কিন্তু কথা বলছিলাম তো তখন কিন্তু এটা আমি তো
আচ্ছা, আমি I'm starting from the very beginning again. Okay,
Okay, sir.
if there is any problem, please call me over my phone.
Okay, sir. I was trying to call him.
I'm starting again. If you find any problem, please call me.
Okay,
So
sir.
I'm discussing about design of frequency selective surface by artificial neural network to reduce harmful effect of electromagnetic wave. That means here are mainly three parts. One is electromagnetic wave or microwave. What is its harmful effect? We should know first. Then, what is the remedial step? Remedial step is the design of frequency selective surface for protection of EM wave. And third step is what will be the use of artificial neural network as machine learning to design frequency selective surface. So there
Sir,
are three. Yes.
sir, I am interrupting. Sir, your slide is not changing.
No. I am not changing the slide yet. This is the
Okay,
first slide.
okay,
Huh.
sir. Okay, sir.
So there are three parts. First, I am discussing about the electromagnetic it consists of wave which have electric and magnetic energy, and in that case electric and magnetic energy will move together throughout the space, and electromagnetic radiation can be divided in different parts depending upon the frequency. Say we are discussing about ultraviolet or X-rays. They are very powerful and they have the power to break down chemical bonds. That means it has the power of ionization. But we are discussing mainly about electromagnetic radiation below the frequency range of ultraviolet rays. That is non-ionizing radiation. That means basically electromagnetic wave which are used in microwave oven, for satellite communication, mobile communication, etc. What is the problem regarding harmful electromagnetic radiation in the environment? The main problem is radiation. Why there has been enhancement? Number one reason is that there is tremendous leap in the demand of cell phone technology. As a result, there has been uncontrolled and unmonitored installation of cell phone base stations, especially in densely populated areas. Number two, in urban areas, increasing rate of use of microwave oven resulting in enhancement of electromagnetic radiation. And point three is that for disinfection and decomposition of biohazardous wastes, microwaves are being used. And for that, microwave radiation took place throughout the society, throughout the village, throughout the urban areas. And what will be the ill effect, or what are the ill effects now? Regarding that, Professor Girish Kumar of Bombay IIT, he has done a survey. He was requested by Government of India in 2012 to make a survey regarding harmful effects of electromagnetic radiation. And that report was submitted in 2015. From that report, we come to know that microwave radiation can damage placental barrier of a pregnant woman due to presence of high water content. That is, a heavy use of EM wave may be dangerous for a pregnant woman. Number two, large number of birds like pigeons, sparrows, swans die each year due to interference from the cell tower radiations. Number three, in the production of wheat and corn fields, especially by the survey of Girish Kumar, we come to know that in Punjab and Haryana, there has been reduction in wheat and corn due to electromagnetic radiation. Basically, in the fields where electromagnetic radiation is much more, we have seen that in that fields, there has been reduction in wheat and corn production. Number four, microwave radiation may harm mental health of human being. And number five, and this is most important, this radiation may cause hormonal imbalance. And one thing I can say that on example of hormonal imbalance, if heavily used mobile phone by women, I am giving an example. The woman generally who used mobile phone in night more than 6 or 7 hours per night, in that case, melatonin hormone secretion becomes very much minimized, and as a result, this may result in breast cancer. So what measures we should take as remedial steps? That means how we can protect ourselves from these ill effects of EM radiation. It has been recommended to regulate power emission of the base stations, and for that, increase in the number of base stations has also been recommended. And treatment of biohazardous waste in a protected and controlled environment to prevent leakage of microwave radiation into the environment has been suggested. But problem is that if number of base stations are increased, if biohazardous wastes are treated for disinfection in any controlled environment, implication is that financial cost will be very high. So what will be the alternative? Better alternative is the use of frequency selective surface. What do you mean by frequency selective surface? Basically, frequency selective surfaces are electromagnetic filters which may filter or reflect or transmit selectively. Properly designed FSS and construction of building, protective gear, waste treatment chambers using it must be helpful in preventing the ill effects from radiation of EM waves. Few examples of protective measures, say hospitals, healthcare centers, there frequency selective surfaces may be used. How? The walls of the ward of specific patients may be constructed with a layer of frequency selective surface. This shall prevent EM radiation of high strength from entering the area. Thus, the ailing patient can be protected from EM radiation. In agriculture field, properly designed FSS can also be used in agricultural field or in rural areas, which shall prevent the radiation from cell towers, that is mobile cell towers. That means electromagnetic wave in the fields will be minimized. But this use of frequency selective surface above the corn field or paddy field or wheat field, that will allow crops from getting rain, air and sunlight, that will not be burned, but EM waves will be burned. And household appliances. One example I am citing here, say working frequency of a microwave oven is 2.4 gigahertz. If at the time of cooking this microwave signal comes out, that will be harmful for the person who will stand nearby the microwave oven. Previously, door of microwave oven was made by traditional glass, so harmful effect was there. Presently, door of microwave oven is made of frequency selective surface and it will reflect 2.4 gigahertz. That means at the time of cooking, no microwave signal will go out of the microwave oven. As a result, efficiency of cooking will be increased, and there will be no harmful effect as the microwave will not come out of the microwave oven. And in residential areas, in our residences, window screens may be made of frequency selective surface which will not allow to enter EM wave of high strength at the time of sleeping or relaxing. But at busy time, window screen made of FSS may be removed to allow the radiation so that mobile phone or other electronic gadget can work properly. This will also minimize the harmful effect of EM radiation. Now, regarding biohazardous waste, say biohazardous waste means in hospitals, in any factories, in any industries, in any agricultural fields, or in vehicles, a lot of biohazardous production are given out, and there is chance of infection from this biohazardous waste. So our duty will be to disinfect that waste. This disinfection is generally done by microwave, but if it is done openly, that will be very harmful for the people who resides within 2 or 3 kilometers of that area. So presently, a microwave chamber is generally built with the help of frequency selective surface, and within that chamber, that treatment is done. As a result, no microwave will go out of that treatment area, and harmful radiation or harmful effect of EM wave will be reduced in this way also. So far I have discussed is the harmful effects of EM waves. Now I want to discuss what is the protecting measure. Protecting measure is the use of frequency selective surface. Now I shall discuss what is frequency selective surface, and in third point I shall discuss what is the utility of ANN to design it. So now FSS, regarding FSS means frequency selective surface. It is possible to fabricate frequency selective surface by metal sheet, or by using metal film, or by transparent glass or flexible sheet. The designer may select frequency band to pass, or to select a frequency band to reflect, or a particular frequency band to absorb. Combination is extremely large. Each combination shall address different problems. Actually, in communication engineering, filter is a fundamental and useful circuits. But in microwave, counterpart of filter is frequency selective surface. It is wireless. Frequency selective surface basically is a two-dimensional array of metallic patch within a substrate, or that of apertures within a metallic screen. I am not going into detail about the application of frequency selective surface, as I have already discussed regarding its application to protect harmful effects of electromagnetic waves. Except that there are several applications. I am only telling that I am only mentioning that applications. I am not going into detail. It is used in satellite as dichroic filters. It is used in protecting radars. One example I am giving here. Suppose this radar is in Kolkata. our plane is flying over Calcutta, and if any enemy plane at the time of war, they will try to destroy our base station. So in that case, they will have to know where is the radar in Calcutta. In present days, generally enemy planes, they try to know the position of the radar by using EM wave. EM wave is given from the enemy aeroplane, it comes to the radar. After reflection, it again comes to the enemy plane. They know the position. Then by bombing, they can destroy the radar system. But if this radar is protected by frequency selective surface, in that case, any EM wave transmitted by enemy plane will be absorbed. So it will not be reflected, and it is not possible for them to know the position of the radar. It is stealth technology. But our own plane, whenever they will transmit EM wave, the radar will reflect that EM wave, and our plane and radar, they will communicate it. They can communicate it between themselves. But in case of enemy radar, their EM wave will be absorbed by the radar with the help of frequency selective surface. This is the use of microwave oven, which I have discussed earlier. This is the design of frequency selective surface. Basically, there are two types of frequency selective surface. One is patch type and another is aperture type. Patch type means, you can see here, there are periodical two-dimensional array of metallic dipole patches on a screen. Its frequency response is just like that. That means just like a band stop filter. It means that around the frequency of 8 to 8.2 gigahertz, it will not pass, but other frequencies will pass. This is the complementary type of frequency selective surface. It is called aperture type frequency selective surface. Its response is just complementary. It is band pass type. That means around 8 gigahertz, the frequency or that signal will pass through the FSS, other signals will not pass through it. This is different types of design of element of frequency selective surface. This is just like a square patch, and inside the patch there are two slots or slits. By using this element, we can design this type of frequency selective surface, and its frequency response is just like this. The difference between the first two and this is that here bandwidth is much large. That means this is a band stop type filter and bandwidth is very large, broad bandwidth. This is another type of frequency selective surface. Its implication is that if you rotate it in 10 degree, 20 degree or 30 degree, its response will not be changed. So this is polarization independent frequency selective surface. This type of frequency selective surfaces are being used in our home appliances, in agriculture field, in battlefield, or in hospital. One example is given here. This is the screen of frequency selective surface in a building, and this will reduce the strength of electromagnetic wave in any hospital or any educational institute or any residence, and as a result harmful effect will be reduced. This is the fabrication, that means practical type of frequency selective surface which are being designed in our lab. This is the frequency response. This is another type of frequency selective surface which has been designed by a laser cutting machine, and this laser cutting machine is a patent of our lab, and by the use of this laser cutting machine we can fabricate frequency selective surface, and this work was done collaboratively in collaboration with Defense Research and Development Organization DRDO. This is the testing equipment. Response is just like this. One important thing I am discussing here, say there is a pass band or stop band. Now we want to change the pass band or stop band. That means it is called reconfigurable frequency selective surface. Here one example is there. Response of frequency selective change upon light at dark time and in daytime and in night, its response will be different. This is at daytime and response, sorry, this is at night, this is at daytime. Daytime means there is 5000 watt bulb and response has been changed. And that reconfigurable frequency selective surface can be designed with the help of pin diode or varactor diode also. When pin is off, you can see this is the response, that is band pass type, and when pin diode is on, response is just like this, band stop type. This is another type of frequency selective surface. This is reconfigurable frequency selective surface. You can say, or you can see here that some varactors are used in this design, and voltage against the varactor diode is being changed. As a result, you can see that stop band is being shifted. At the first figure, resonance frequency is around 3 to 4 gigahertz, around 3.6 gigahertz. In second figure, it is around 3.1 gigahertz. In third figure, it is around 2.4 gigahertz. This change has been done by changing the voltage of varactor diode. This is another frequency selective surface. It is also reconfigurable. Here resonance frequency is around 2.4 gigahertz, and the second figure resonance frequency is around 3.2 gigahertz. And this change has been done by changing the voltage only, without changing any structural point. Now, our next target is to discuss how I can know that if the element is that, its periodicity is that, what will be the pass band, what will be the bandwidth, what will be the stop band, what will be the bandwidth. There is no fixed rule. So we want to develop that rule with the help of artificial neural network. Before going into artificial neural network, I am citing three or four examples regarding curved type of frequency selective surface. Till now, I have discussed only planar frequency selective surface. Planar means there is no curved structure. It is two-dimensional and planar structure. If we want to design the nose of or body of an aeroplane by frequency selective surface, it will not be possible to design that with the help of planar FSS. So in that case, we shall have to design curved FSS. To design curved FSS, these different types of elements are being used. This is a spherical frequency selective surface, and element is tripole 1, and its response is very good. This is band pass type. This is single layer frequency selective surface. And this is the case of double layer frequency selective surface, and its difference between single layer and double layer hemisphere frequency selective surface is that in this case the upper portion is not so stable, but in that case upper portion is very stable, and rising and falling edge is not steep. Here rising and falling edge is very steep, that is selectivity is very high. There are the examples of curved frequency selective surface. There are the responses. Now I shall discuss about the design procedure or to establish a rule regarding the relation between the input parameters and output parameters. What are the input parameters? Input parameters is that we want to design a frequency selective surface whose bandwidth will be this, number one. Number two, this will be band pass or band stop. Number three, what will be the difference between stop band and pass band? They are the input parameters. And I shall have to design the frequency selective surface. What are the parameters? This may be curved one, this may be planar one. What will be the dimension of its unit cell? That is, what will be the length? What will be the breadth? What will be the gap in x-axis? What will be the gap in y-axis? These are the parameters that we shall have to calculate. But there is no fixed rule, we shall have to establish the rule. And for this, machine learning is being used. Here, NN is being used. As introduction, first I should say, why do we require ANN? Normal computation is performed using sets of fixed rules. So the requirement here is a set of fixed rules. In the cases where fixed rules are not available, the computation has to be performed by developing the rules, just like a biological brain. In our case, in case of design of frequency selective surface, there is no really fixed rule. So we shall have to develop the rules just like a biological brain. What are the biological inspirations? Animals are able to react adaptively to changes in their external and internal environment, and they use their nervous system to perform these behaviors. An appropriate model or simulation of the nervous system should be able to produce similar responses and behaviors in artificial system. Artificial neural system actually is just a replica of human neurological or human nerve system. In human neurological system, there are dendrites, soma, axon, just like this biological inspiration I'm telling here. First, there are dendrites. The dendrites collect responses. Then that responses go to the soma or body where there is a nucleus. Then it propagates to the axon. After axon it generally goes to the synapses. After synapses, the responses will go to the dendrite of the next neuron. In this way, any response from hand or leg or eye or skin will go to the brain, and action which we will have to take will come from brain to the limb. Now, artificially, we have tried to develop that neurological system. For this, for simplicity, to avoid complexity, we have taken here 2 inputs and 1 output first. And for training of the network, we have taken 2 hidden layers. In first hidden layer, there are 3 functions F1, F2, F3, that is there are 3 nodes. And in the second hidden layer, there are 2 nodes or function F4 and F5. Now say some response is at the input of X1 and X2. Some arbitrary weight will be given W1 and W2. And E will be equal to X1 into W1 plus X2 into W2. After calculating the value of E from X1, X2, W1 and W2, we shall have to calculate function of E. Generally, sigmoidal functions are used in case of ANN. So once function of E is calculated, Y is calculated. So in this case, say X1 and X2, 2 inputs are given, and weight WX11 and WX21 is given arbitrarily. That means X1, X2, WX11, WX21, these 4 parameters are known. So E will be known. Once E is known, F1 will be known. Say this is Y1. So Y1 is calculated. Similarly, Y2 will be calculated. For Y2, we shall have to know X1, X2, WX12 and WX22. Next, Y3 will be calculated. So in first hidden layer, 3 functions of or 3 nodes, they are known. Now F4 or Y4, this is a function of F1, F2 and F3. Once F1, F2, F3 or Y1, Y2, Y3 are known, F4 or Y4 will be known as Y4 is equal to W14 into Y plus W24 into Y2 plus W34 into Y3. And W14, W24, W34, they are being chosen arbitrarily. So Y4 is being calculated. Similarly, Y5 or F5 will be calculated. Once F4 and F5 is calculated, it is very easy to calculate F6. As F6 is a function of F4, W46, F5 and W56. W46 and W56 will be arbitrarily chosen. Now, Y is calculated as a function of X1 and X2. Say X1 and X2 are 2 given input, and by choosing arbitrary weight, it is possible to calculate Y. This is the calculated value of Y. But we know if X1 and X2, say X1 is 0.1, X2 is 0.2, then the value of Y will be 0.3. but after calculation say the value has been 0.7. So there is a great amount of error. That error is delta. That means z minus y. Y is calculated value and z is the actual value. Actual value minus calculated value, this is the error. Why there is the error? As these weights have been chosen arbitrarily. This error will be propagated in back to the backward direction. Once delta is calculated, delta 4 will be equal to W46 into delta. Delta 5 will be equal to W56 into delta. Next, delta 1 we shall have to calculate. Delta 1 will be calculated from F5 and F4. Here is delta 5 and delta 4. Delta 5 into W15 and delta 4 into W14. After addition, we shall get delta 1. Likewise, we shall get delta 2, delta 3. After having these errors, we shall have to modify the weights. So previous weight was Wx11. With Wx11, this factor will be added. What is the factor? Eta is a constant. Generally, it is taken less than 1. It is 0.2 or 0.3. You can choose it arbitrarily. But delta 1, it is calculated by back propagation. And F1 DE, differentiation of F1 with respect to E. And X1 means the input. After addition of these two quantity, you shall get the new weight Wx11 dash. And likewise, you can calculate all the new weights. All new weights are calculated. After calculating all the new weights, you will put another two input. And you can calculate the output again, but you know the actual output for this particular input. And by difference of desired output and calculated output, again you will get an error. That error will be back propagated. After back propagation of error, the weights will be modified. Once the weights are modified, the network weights are different, and again you will put the third input and you can calculate the third output. So there will be again calculated output and desired output. By getting the difference between them, again you can calculate error and that will be back propagated. And this will go on still error becomes less than 10 to the power minus 8 or 10 to the power minus 10. When error will be less than 10 to the power minus 8 or 10 to the power minus 10, then you can say that yes, now this network is trained. Now if you put any input, you will get the actual output almost without error. So for training the network, you should have some training parameters. That means some input and some output. Say you will have to first collect 100 set of data. By 100 set of data, you will train the network. Once you train the network, for any input, you will get your actual output almost without error. And this training method has been used in designing frequency selective surface. What are the parameters there? First, this is the dimension of the element, that is A is length, B is breadth, C is periodicity in X direction, D is periodicity in Y direction, and as a result you can calculate what is the resonant frequency, what will be the bandwidth, and what will be the difference between pass band and stop band. This is the synthesis type network, not analysis. But if you want to design, then your input parameter will be this one, that is D, F, B. Input parameter will be D, F, B. That means you can see that you will have to design a frequency selective surface whose bandwidth is given, resonance is given, difference between pass band and stop band is given. You will have to calculate A, B, C, D, and that is possible by this network where input is D, that means difference between pass band and stop band. F, that means what will be the resonant frequency. B, that is what will be the bandwidth, and it is pass band or stop band, that will be mentioned here. And as you will have to, you can calculate what will be the element dimension, then what will be the periodicity in X direction, what will be the periodicity in Y direction. Researchers have worked a lot on that type of frequency selective surfaces regarding reduction of resonant frequency multiplication operation like this in our lab. And in our lab, it has been possible to train artificial neural network which can tell it is your requirement, then what will be the input parameters. It has been possible. And for better to the power minus 10, to minimize the error, say error less than 10 to the power minus 15, then PSO and GA has been hybridized with it, and we have got much more better result. And in our lab, we have got a patent regarding this, and this is our total publications, and that's all. Now, if you have any question, you can ask.
Thank you so much, sir, for delivering such an informative session. Sir, no questions are there in the chat box from our participants. So, sir, I am sure that all the participants found it highly insightful and useful. And your explanation of how artificial neural networks optimize the frequency selective surfaces to mitigate EMOF effects was truly impressive. So, thank you, sir, for sharing your expertise.
So thank you to all. So may I leave now?
Sir, before you leave the meeting, I just want to share my screen for a small token of appreciation and gratitude.
Okay.
Sir, is the certificate visible?
Yes, it is visible.
Okay, sir, we will mail the certificate to you.
Okay, thank you.
Thank you once again, sir, for your kind and valuable presence.
Okay. Good afternoon and thank you to all. I am leaving.
Sir, one of the participants is asking a question.
Okay. Without any hesitation, please ask me without any hesitation.
Ask him to post it on the chat box.
Bhuya, you can ask. Satyajit Bhuya. Satyajit Bhuiya.
Hello, Satyajit Bhuiya, you have raised your hand. So if you have any question, then you can ask. Okay, sir, we are not getting any response from him. Sir, thank you.
Okay, thank you. If there is any question, you may send my in my email also. Okay.
Yes, yes, yes.
Minaki,
You
please
can
share my
find.
email.
Okay,
Share
okay,
my
sir.
email to all of them. Okay.
You
Okay.
can. Everyone can easily find it from his official website of Kolkata University.
Okay.
So on that note, we are concluding the session for the third day of FDP. We request all the participants to join tomorrow's session exactly at 3 p.m. The meeting link will be shared in the WhatsApp group prior to the commencement of the session. And regarding the attendance form, it will remain live until 5 p.m. That has been already shared in both the chat box of Google Meet and YouTube. So thank you all participants for attending today's session. See you all in tomorrow's session. Have a nice day.